Welcome to this video on linear inequalities. We have here three inequalities and we've got to find the region R which is bounded by them, and by shading we've got to show clearly that region. So the first thing we need to do is consider these as the equations of straight lines and find those lines and mark those on the graph. So the first one is y equals 2x plus 1. I'm just adding 1 to both sides. Okay, and that's presenting it in the form of y equals mx plus c, where m is the gradient and c is the y-intercept. I'm just going to write that down here. Okay, now you can do that with all the straight lines involved, set them in that form, but in some cases it's easier to use a different method, which I'll show you in a moment. But for this one, y equals 2x plus 1, it's got a gradient of 2 and it goes through the point 0, 1. So I'm just going to mark a couple of points on it there and there, because for every one I go across I go up 2, and that's the straight line that I'm interested in for the first one. I'm just going to draw it as a solid line for the moment, okay, because it can be changed on this tablet into a dashed line if I need to. So that's the line y equals 2x plus 1. Now the second one, I could use the same sort of method, but I'm going to use what we call the cover-up method, and that's easier when you've got numbers in front of y and x like this. Okay, so what I'm going to do is simply set x equal to 0 to see what y would be. Okay, so when x is 0, think of this as an equal sign. 3y equals 18, so y would be 6. Okay, so if x is 0 and y is 6, then I know that the point 0, 6 is on the line. And now I set y equal to 0 to see what x would be. And when y is 0, 2x is 18, x equals 9. So what I've done is I've found 2 points that are on the line, and that would be the point 9, 0, you see. So I identify those 2 points. 0, 6 is there, and 9, 0 is there, and I join them together because that is a straight line. Okay, if you know 2 points, you can define a straight line. So I'm just going to take that line through. Okay, I'm going to start here, and it will go through 6 and through 9 like that, and then off onwards like so. All right, so that's the second graph line drawn. And the third one is the line y greater than 2. Well, the line y equals 2 is a horizontal line where all the y coordinates are 2, so I just need it to be greater than 2. Now, if you do those faintly in pencil, you can correct them or change them if you need to into solid or dashed lines. So the first one, y minus 1 less than or equal to 2, was including, so that's a solid line, so that stays as it is. This one is not including, it's less than, so it should be a dashed line. So on the tablet I can change that just by taking out some of the line like that, and obviously if you've drawn it in pencil you can easily correct it and adjust it. Alright, so that's the first one, and then the same also applies to this line here. That's also not including, so it needs to be a dashed line. Okay, so that's the first thing I've done. Now the shading, what I tend to do here is, it says by shading show clearly the region R. So it's not asking you necessarily to shade R, and in fact that isn't the best idea anyway. It's better to shade the unwanted region, and that will make R much clearer to see. So what I'm going to do here is I'm going to shade the region I don't want, which is where it's greater than, in other words, above the line. So this is the bit I don't want, so I'm going to shade that in, Okay, now it's just faint shading to one side of the line. You don't have to do too much of it. Okay, and then I've got to shade the bit where this is greater than 18, which is above the line. So I'll just do that like this. Now I can see already where the region R is going to be, so I can kind of focus in on that. Okay, so I'm shading the unwanted regions, and then because I want the bit where y is greater than 2, I can shade in underneath it. Okay, and then I'm clearly showing the region R, and I'm going to label it here. And what I'm going to do, just to be absolutely clear, is just make a statement that unwanted regions are shaded. Unwanted regions shaded. Okay. The reason I'm just doing it that way is because you see, if I shaded the wanted regions, the bit R would have 3 bits of overlapping shading inside it, and it would look very confusing. So it's a lot easier if you do it that way around. Okay, now this next question is about showing inequalities on a number line. Really simple, you've just got to know what to do. So there's 2 of them here, and this is the inequality where x lies between -3 and 2, but it doesn't include -3, but it does include 2. So I'm going to do that next to it here. Here's the number line. So -3, I'm going to put a circle, okay, like that. And I'm also going to put another circle at 2, okay. Now one of those circles has to be shaded in, and it's the one where it includes. So it includes the 2, so that has to be a solid shaded in circle like that. Okay, and then I just simply draw a straight line connecting those 2 points together. As simple as that. Okay, now the second one is just got a single-ended inequality. So x is greater than -1. So all I do is I find the point -1, which is here, put my open circle on it because it's not including -1, and then simply draw an arrow pointing away to the right because x is anything greater. Now I don't go up to any particular value, I just go a few units along and then just put an arrowhead at the end, just to show that it carries on going up in that direction like that. Okay, and it's as simple as that. Now here we have a 3-part inequality, and we just got to be careful here to follow certain rules. So what I'm going to do is make sure I do the same thing to each part of the inequality. Just bear in mind, if you ever multiply by a negative number, you need to change inequality signs round. So try to avoid that if you can. So let's make a start, and I'm going to notice a common denominator of, I've got a 2 there and a 3 there. So if I multiply the whole thing by 6, I will clear the fractions. So let's do that first. So I'm going to have, that's going to end up becoming, if I times that by 6, it's going to become 9 minus 12x. Okay, 9 minus 12x. That's going to be less than or including 5, 6's are 30, so it's going to be 30x minus 12. Okay, and that's going to be less than 60 minus 2x. Okay, now I'm going to take the 12 here and add it to every part, okay, to clear that minus 12. So if I add 12 to 9, I'm going to get 21, okay, minus 12x is less than or including 30x, which is less than, and I've just got to add my 12 to here as well to give me 72 minus 2x. Okay, now I'm going to add 12x to each part. So I'm doing it a step at a time because otherwise it's likely that you would go wrong. So 21 less than and including 42x, that's adding 12x to 30x, and that's going to be less than 72. And instead of minus 2x, if I'm adding 12, it's going to be plus 10x, you see. So I've done the same thing to each part. Now, if I look at the left-hand part now, okay, so at some stage it's easier to consider each side separately. So if I just look at that bit there, I can see straight away that 21 is less than 42x, which very conveniently means that 21 over 42 is a half, you see. So 21 over 42 is less than or including x. Okay, so that's a half. Okay, and if I now look at the other side, I'll just highlight that in a different color. So if I now consider this part here, 42x is less than 72 plus 10x as a separate inequality, you see. If I now take the 10x from both sides, that's going to give me 32x is less than 72. Okay, just looking at this part here. And therefore x is less than, that should be 72. And therefore x is less than 72 over 32. Okay, and 72 over 32 conveniently cancels down to, well, it's going to be 36 over 16. It's going to be 9 over 4, in fact. 2 1/4. 9 over 4. Okay, so I've got that x is less than 9 over 4, and it's bigger than this, which is a half. Okay, so I can now show that on the number line. So there's my half. It's bigger than including a half, so it's a solid line, solid circle rather, and it's going up to 2 1/4. Okay, well there's 2 1/2, 2 1/4 is exactly there. Okay, but not including. So to show that on a number line, I would simply do that. Okay, and the next thing I've got to do is identify all integer solutions. Okay, so the integer solutions are going to be, well, 1 and 2. They're the only two whole numbers that lie in that range. So I just need to state integer solutions, x equals, okay, and we sometimes just put them in sort of curly brackets like that, 1 and 2. Okay, and that is the answer. So you just got to be careful with these, and at some point it's often easier to work in two separate parts. Okay,